Students, welcome back to another video session. In this video, I'm going to explain you how we can find the minimum from a given input array. This is a very important step because this will be the major step of the next sorting algorithm which we are going to discuss in the next video, which is selection sort. So let's go ahead and try to understand how this algorithm works. This is a very simple and easy to understand kind of iterative algorithm to find the minimum from the given array. Now here I have shown an array which is which you can either read it from the keyboard or initialize it, or you can randomize and store it in the array. Okay, so this is the input array. The output from this algorithm is two things. One is the position of the minimum. Okay, for example, here in this array, the minimum is 1 and the position of the minimum is 4. Okay, so basically you can either output any one of them. You can either give the position as the output of the minimum. Using the position I can get the element, or you can actually output the element itself. Okay, or it is useful if you can return both variables as the output of this algorithm. Okay, let's see how we can calculate the minimum from a given array. With slight modification, you can also find the maximum of the given array. Okay, in this algorithm I'm going to make use of three variables. One is the variable I is a loop variable which indicates the starting position of comparison, because based on the comparison we will find the minimum. So it indicates the starting position of the comparison, and these two variable keeps on getting updated as we examine the array elements from position 1 up to the last position. Okay, so the I value will be ranging from 1 to n minus 1, because here the number of elements n is 6. It will go all the way up to n minus 1. Okay, or you can say in the loop I less than n. This is the limiting value of the loop variable I. Now let's start from the beginning. Okay, so what we do is at every position of examination, for example, when we start from position 1, that is our a of I, we will keep on checking whether it is less than minimum or not. Please note that before the execution of the loop, these two variables which we will be outputting by the end of the algorithm, position and the minimum, are initialized to 0 and a of 0. This is like assuming the minimum is in the first location 0, and as we progress in the algorithm we will update these two variables. Let's see that now. You can see here the I value is now 1. Now this is the element which we are going to compare it with the assumed minimum. The minimum that we have assumed is 42, and the assumed position of minimum is 0. Now here a of 1 is less than minimum is true. When it is true, whenever this condition is true, we will update this variable and this variable. Okay, how we are going to update? We will update position to I, and we will update minimum to a of I. So position will be updated. You can see here the position has been updated to the value of I, and the minimum has been updated to a of I, which is a of 1, which is 12. Okay, please note that whenever this condition is true, we will update this variable and this variable. Let's go ahead and see what happens next. Next position of comparison is from position 2. Please note that we will no longer compare the array element with the first assumed minimum. We will always compare it with whatever the right now 12. Okay, now a of 2 less than minimum is false, because a of 2 is 13 and minimum is 12. So the condition is false. There is no updation. Next, going ahead again, next element is from position 3, which is 51. The element at position 351 is not less than the minimum 12, so there is no update. The condition is false, means no update. Next, going to position 4, element at position 4 is 1. Now a of 4, which is 1, less than minimum, which is 12, is true. So whenever this condition becomes true, we will update this and this variable. Okay, so in the next you will see position has been updated to 4 and minimum has been updated to 1. That is based on what I told you previously. Position will be updated to the value of I, minimum will be updated to a of I, which is a of 4, which is 1. Going ahead, now I value is 5. The element at position 5 is 101. 101 is less than 1, which is false, so there is no update. Since we have reached now the end of the array, now whatever the value that is being stored in this variable is the final result we are trying to find, which is minimum is 1 from position 4. So you can write an output statement saying that the minimum from the given array is whatever stored in this variable at position whatever is being stored in this variable. Okay, so it will output as minimum stored in the array is 1 from position 4, something like that. Okay, now let's go ahead and draft a algorithm for this one. Okay, so here the input for this algorithm is an array and the output is either the position of the minimum or minimum itself from the given array. Okay, and the steps are very simple to write. Step 1 is reading the input array. B, you see here we start comparison from the value at position 1. We will start comparing from position 1. So I indicates the position of comparison. So I equal to 1 and the comparison goes all the way up to the last position. Okay, so that is I less than, you can say n, where n is the number of elements in the array. If n is 6, I less than 6 means it will be true until the value of I is 5. For 6 it will be false and there is no need to compare for position 6, and the value of I is incrementing every time, so I plus plus. Now here what I'm doing is every time I compare the array element a of I is less than minimum or not. So this is what we do at every step. Okay, so the same thing I'm going to write it in the algorithm. Okay, so if a of I is less than minimum, we will update two variables. Minimum will be updated to a of I. Okay, so this is what we do. If this is false, we will not update it. If this is true, what we will do is we will update minimum to a of 4, which is 1. Okay, you can see here, and position is updated to I. So same thing I'm going to do here. Position is going to be updated to I, and here you can say, you can output here output or you can simply say display the value of minimum, and also you can display the value of position. Okay, so this will output the actual output which we are trying to compute through this algorithm. Okay, now I'm going to do it in NetBeans. I'm going to create a package here. I'm going to call it as minimum, something like this, and once I create a package, you can create a Java class, and I'm calling it as minimum from the array, something like this. Okay, here let me create a main method. Quickly let me declare an array. Let's say size is 10. Now I'm going to read the step 1 is getting the input array. There are very many ways to get the input array. You can initialize, you can randomize, and let me randomize it. Okay, new, after new press control space, use the first constructor. Now I'm going to have this. Why there is an error here? Because we need to int a equal to new int a of 10, int a equal to new data type, and in the bracket we put this one. Okay, so now here I'm going to store the random numbers which are getting generated, which is obj.next int. We used similar code for generating the input random array for the bubble sort algorithm. Okay, now you can, if you want, you can display it. You can say here the input array is something like this, and instead of this hard coded value you can replace it with a dot length. Same thing you can do here as well. Okay, and here let me display the array system.out.print. You can display a of I. Okay, so this completes step 1. Now step 2 is this one. Okay, for I equal to 1 to n, with this simple step you can actually compute the minimum. For now here you can change it to a dot length, and inside the loop a simple if condition. If a of I is less than minimum, we need to update minimum with a of I and position with I. Please note that before the computation of the loop we have to initialize, or we have to assume minimum is a of 0 and position is 0. Okay, you need to declare them int. Now once you format it, Control Shift F. Okay, once you are out of that loop, step 3 is to output the result. Okay, now I'm going to output the minimum in the array is, okay, plus minimum, and you can also say the position of the minimum is plus POS. Okay, so you can display them in separate lines. Run it. You can see here the minimum is 7 from position 1. Okay, you can randomize and run the algorithm, rerun the algorithm. Minimum in the array is 2 from position 1. Okay, just to verify our algorithm is working fine. The minimum is 11 at the last position. Okay, so this confirms our algorithm is working perfectly fine. I would like to show you here another thing is, just by changing this less than to greater than, the algorithm will, instead of finding the minimum, it will start computing the maximum. Okay, now you can see here the output is, the array is outputting maximum instead of minimum from position 4, just by changing the less than symbol to greater than symbol. You can see here the maximum is 89 from position 9. Okay, so this is one thing we need to observe. Another thing is, you need not update minimum at all. You need not do that at all. You need not use minimum variable at all. You can just comment it out. I think this is the simplest one. Let me go back to what I showed you. In the next video, I'm going to show you how we can convert this to a simpler version and generalize it. By generalizing, I mean that you can find minimum within the range of the array. For example, if you want to find out minimum only in this range, what you need to do. Also, I will modularize it. That means I'm going to write a separate method for finding minimum. Okay, so I'm going to show you that in the next video. But this is what I'm going to do it in the next video. I'll specify the starting index and the ending index. For example, if the starting index is 1, ending index is 3, I need to find the minimum within this range. So minimum will be 12 in this range, and the position is 1. Okay, so same algorithm, same concept will be applicable here as well. Okay, let me take you to okay, let's say we are trying to find out the minimum from this range. For example, let's say I'm trying to find out the minimum from this range. So what happens here is, the minimum is 1 from position 4, but the algorithm, nature of the algorithm remains same even for this subarray. That means we will assume this as the minimum, and we will compare from the next position from here up to the end of that subarray, which is 4. Okay, so this is what I'm going to show you in the next video, which is very simple to do it.